I've done a couple of recent videos looking at Nurbs modelers and how you can use those along with something like Blender. In one of the videos, somebody asked me about doing 3D type and how that would work out in a Nurbs modeler. Type can be really challenging in a polygon-based modeler. It turns out that in Nurbs modelers and CAD applications, type is really awesome. So what I figured I would do is generate an example. And this example is actually based off a real set of projects that I've worked on over the past couple of years dealing with type, and specifically type that has been developed in Adobe Illustrator, where you develop either outlined type or you have custom art that you need to convert into a Nurbs modeler and then take that into Blender. So what we're going to do is we're going to take this over into Moi, and I'm going to show you how I would go about doing this in order to prepare this to then send into Blender. I wanted to show you this in Moi because it has the ability to import PDF files, so you can bring in Bezier-based vector art and convert it into equivalent Nurbs for then doing Nurbs modeling. I didn't see that Plasticity had that ability. So let's come in and import the vector art that I have set up. There we go. So it has converted this into equivalent Nurbs data that we can work with. The first thing that I want to do is round some of the corners so they're not sharp. With this object selected, I come down to construct and use the fillet function. When it's a curve selected, it gives me the ability to select specific corners to then run the fillet function. So I click done and then specify a value. So let's do this. Let's go to 0.04, or maybe let's do 0.06, just something a little bit larger like that. And I think that works pretty well. But what I do want to do now is show you some of the really kind of cool editing abilities you have. If we look here in this space, we've got something that doesn't come to a complete corner, and it's got this little bridge right there. So I'm going to click done so it validates that last previous operation. And I need to make these come right to a corner point. So I'm going to separate this geometry. What it does is it just takes this curve and separates it into all of these little segments. So you can edit things like this quite easily. I'm going to delete that one. And I'm going to delete that one. Now, the Nurbs editing system can figure out where the apex point should be for both of those. With both of those segments selected, I can come over to Edit, click Extend, click Done once, and look at that. It figured out where those were and just created the correct replacement for that segment. So let's do the same thing over here. Select each of these and then do Extend. There we go. So now that's done. I need to just come back in and join these back together. So now I can gain access to those with the fillet function. And I can just find a value that's appropriate for those, for those areas. There we go. So we would just do the same thing, progress down through fillet. I'm going to do all of these with the same value. Let's do 0.06. There we go, so it's equal. Let's come into each of these now. Let's say we want to produce an outline. We want to produce a big bevel. So this is where we would come over to the offset function and we would find an offset value. So let's do this. Let's go up to 0.3. I'll do it pretty big so that this is really apparent. And just click to validate it. It's actually going to remember that value. But see, now it's done something really intelligent. Is these small radii here, it automatically just cropped and created an apex point. So then we can just come in and do the same thing with these points. We can take all three of those, click done, and then we can just apply a new fillet to those. And that's going to be important for a minute because we want matching profiles. Okay, and it's done there, and now we can come over here. And in fact, let's do this to the O on the end. So we'll just come down to offset. We go this way, select here, click to deselect, and then we'll just invoke the tool again. So it remembers the value, which is great. Let's focus in on the C because there are a couple of really interesting parts of this that we actually want to clean up just a little bit. This area has a little bit of weirdness here, and it's got a little bit of weirdness here, and I think I'd like to reconstruct this. So I'm actually going to separate this so I gain access to the individual components. And I actually want to extend this line out. So I'm going to draw a new line there. I want to extend this line down to this point. So I'm going to click the extend function. It will ask me to pick a boundary option, click done, and then it extends that out. Well, the reason I did that, let me go ahead and delete that, is because I actually want right about here to lop off these endpoints. So with these two segments selected, let's come over to the trim function. It'll ask me for a trim or a cutting object. I click that, done. Now I can just select both of these and click done, and it's removed them. So now I can use this as an extending object. So we're going to again click extend, click objects to extend, okay, done. And now pick the boundary object, which is this again, and boom, look at that. It extends that out. And then I can just do the reverse. I can now come in and let's do a trim, select object to trim, which is this, done. And then I can pick both of these, click done, and then I just select the two parts that I want to remove. And there we go. So you see how easy that was to sort of reconstruct this to get better geometry to then perform rounding on. So let's go ahead now. We need to rejoin this. Get that selected, and then we just come back to the join function. Then once again, we can select fillet. For the sake of expediency and speed, I'm going to apply the same value there. And then we'll come here and let's do the same thing. Fillet. And we'll pick the same value. Typically, I would actually take a little bit more care to apply maybe a smaller value here, but that's okay. For the sake of expediency, we're not going to worry about that. Then we can do an offset, produce that, and let's come over and do the R really quick. So let's do the fillet. Select these. That looks good enough. Okay, and let's do this one. Okay, now we're ready to come into the offset. There we go, and let's do the offset again. There we go, and then this one, we need to then produce fillet, like there. Click done, and done. Okay. So now we've gotten all of those generated, and now we just need to create 3D geometry from these profiles. In fact, it looks to me like there was one other area right here that needs to get fixed. And in this case, we have two corner radii here, but we've got one apex point. So we're going to do this a little bit differently. I'm going to come in and put a cutting edge there, select this, and then we're going to use the trim function. Done, and then we just select both of those to get removed. And in this case, I can actually come into a show points, and I can manually move those into place as opposed to trimming. And then I just turn off the points, and I select all of that outer boundary. There's an area right here I need to take care of, and we just join those together. And then we can come over and perform our fillet operation on it. There we go. Select there and done. Okay. Now I would actually, if I were doing this for real, I would actually take care of a few details here and there just in terms of corner radii consistency and things, but I'm moving through this pretty quickly. So now that we've gotten that done, we want to come over and change the position of these center profiles like these. So we're going to move these up. You can just grab and move them up. It's going to try and snap, so I'm going to move it up so it's a little bit higher, like that. And if it's too high, then you can move it back down, or you can start over. For instance, I can come over to transform. They also have a specific move tool. So if I move this up, there's a readout at the bottom with a little d. It's hard to see. It's a delta change. If I want to type in a specific value, I can hit tab and just put in, say, 0.55 as a specific value. That way I can remember it and reapply it if I need to. So those are offset. Now I'm going to come in and name these so that I have sort of specific layer data that I can go back to. Since these objects are selected, the way Moy handles it is you give those a name and it creates a layer automatically for it. So I'll call this source profiles. Okay, and then let's do a select invert, and we'll call these offset profiles. Okay, so we have both of those data chunks saved. So now let's come in and actually create the 3D geometry. So back in the top view, what we do is we select one profile and then the other. And in this case, because one was derived from the other, they should match up pretty well. It's still going to try and do what Blender does. It's still going to try and match up mismatched topology, but you get the best result if things are matched up. So come over to Construct and then Loft. Look at that. Ta-da. This is one of the great benefits of Nurbs-based geometry, is how clean the geometry is. And again, Plasticity would be able to do this, do very similar things. It just doesn't have the importer for AI vector art. So we'll come here and here. Let's do Loft. And you can assign keyboard commands to these. So I'm just doing it so you can see the tools. Let's come over here and loft these together. It's every now and then I always check, because sometimes it won't do a perfect job and you may have to do a little bit more custom work. But also note that it can generate an end cap, and I forgot to have that option enabled, but that's something that's easy to correct. We'll come over here and here. Let's do Loft, and I check, and everything matches up pretty well. So we'll click Done. Now, in this particular case, it created an end cap, and I could just undo and regenerate it. But another thing that you could do is to just actually select that face and press the delete key to remove those. So let's come here to here and do a loft. See there, I'm going to turn off cap ends. And we have to figure out, though, how to generate the caps. But in this case, we're going to do it from the source profile. So I'm actually going to select the 3D geometry that I have up to this point, and we're going to create a name for these 3D geometry, something very explicitly obvious. Okay, so I'm going to come over here and just hide those temporarily, and then I'll select these profiles and just hit the planar button, and it'll generate trimmed counterspaced profiles for me. So I can take both of those. Now let's take these two bits of data that we've just generated, and I want to move it into 3D geometry. So I can click that and say assign the selection to here, and it allows you to see only parts of a layer at a time. So let's come over and turn those off, and I can click to enable everything, and then I can just select all of those, and we want to come up to edit and join those into a volume, or a solid is what it's technically called. Okay, so let's come back over here to these, and we'll have to do the same thing. Select here to here, loft, here to here, loft, done. And then I'm going to select these components, move them up here, and turn everything off so that I can gain access again back to those profiles. Planar, here, and planar. There we go. So I can take both of those and move them back up into this layer. And let's hide those profiles and bring back all of those. So I can just marquee around and join. Now let's come back over here and figure out how we can cap these off. So it turns out it's really easy. For forms like this that don't have a counter space, all you do is come over to the planar function and it'll figure that out for you, that those need to get capped off and joined. And there we go. So that was super easy. The next thing that we want to do is add a little bit of rounding or filleting around these sharp edges. Moi has a couple of algorithms for doing filleting. So let's actually start with the eye. I'm going to select just this face and we'll come over to fillet. And you see it's got library. It's got two solid libraries that are sort of standard libraries they use. They work best with solid objects. So I think 0.06 is going to work pretty well. We'll just use that for right now. Let's come over here and select this one. And let's come over to fillet. Good, it got that. Every now and then it'll give an error. It'll come in. Something about the geometry won't be right and you have to do some investigation. But we'll come here to the C. And there we go. Looks like it got that. Figured all that out for us. And then we'll do R. Yep, got that in. That worked pretty well. They've improved the algorithms a lot. It didn't used to be quite this easy to get good filleting. And there we go. Okay, so now that we've gotten that done, one of the things when you're working with 3D type is that you want to give it a little bit of curvature. And it's flat right now, and it is best, like if we come over here to Blender, we look at this, you can see that type has a bit of curvature. That actually makes it pick up the environmental lighting a little bit better. So we're going to take a look at another really awesome editing feature with a Nurbs system. So there's a deform function that is really, really neat. I'm going to come into the top view and I'm going to create a single reference line that goes just a little bit past the height. And in fact, I'm going to call this, let's name this Deform Profiles. Okay, and just to make this easy, I'm going to turn off 3D geometry so that I have just this single line in place. Now, I need to create a second line that's based on a curve, and I'm going to just do it right over the existing line, hit return, and then we'll select this and let's turn on our points. I'm going to move that down, select this, and also turn on the point just so that I can gain access to these. Now I'm just going to bring that up so that I've got that deformed curve. Okay, so let's come over here and just turn off the edit points function. Let's bring back the 3D geometry, and then we come over to transform and then deform, and what it's saying is it says select objects to flow. So those are the flow objects, the objects that we want to flow. Click done, and then it says pick base curve, and then it says pick target curve for matching, and it calculates. Give it a second, give it a couple of seconds, does a bunch of calculations, boom, and there it goes. It produces the deformed forms for us. And I usually just select these and put these on their own layer. Deformed 3D. Okay. And so that is how I would go about doing it. Now all we need to do is just bring this over into Blender. So now we're ready to take it over into Blender, and all we need to do is export it into a polygon format. So I'm going to select everything we want to export. Come to Export. You save the file, specify the file name. And then we just have some customization parameters. At first, it simply tries to export a small, efficient file, but we really need more resolution because we're going to be doing a high resolution rendering. So the first thing that you do is let's come and specify, instead of sending n-gons, we'll do quads and triangles for greatest compatibility. And then it looks at angles. You can see we've got a shallow angle coming around this way, but we've got more curvature here. So let's drop down our angle for tessellation to 6. We really would like it to put more polygons in the middle of the faces here, so we need to specify a minimum distance so it'll divide anything larger than that value, and that is in your scene units, whatever your scene units is set up to. So I'm going to specify 1 because I'm using inches. In fact, let's go a little bit smaller, 0.5, and then you can just progressively send that down until you get the value that you want. You'll always kind of get to a point where you start generating really small polygons, and you may want to prevent that from happening, so you can do the inverse where we just specify that it not generate polygons below a certain size. It generates normals from the Nurbs data and encodes those into the vertex normals of the mesh. So it's not doing an auto function to generate vertex normals, it's deriving them from the Nurbs data. Click OK. And then we're ready to go over to Blender. So let's just come in now and import in OBJ format. Locate our output folder and the file. And then just do a zoom to selected, and there we go. In fact, let's come over here and do a set origin to geometry. And there is the type. One thing to note, if we come down to object data properties, the normal information is not being auto-calculated even though it's enabled. Come down here to geometry data, do not clear this custom split normal data on there. That is the information that has come from the Nurbs modeler and is encoded in the mesh. If you remove it, it'll revert to doing auto smoothing and it won't be as good as what you got from the Nurbs data. So just something to keep in mind.